Hi, in this video, we'll try and understand more about velocity. Let us take this particular graph where this is a plot of displacement s, this is time t, of an object moving in a particular direction. Let's assume these time intervals marked here are each 1 second, so there are 4 seconds here. And at each second, after each second, the object is found at some position. After the first second, the object is here, which is 2 meters away from the original point. And after 2 seconds, it has moved 4 meters away. And after 3 seconds, it's moved 6 meters away. And after 4 seconds, it moved 8 meters away. So we know that the velocity is nothing but displacement over time, right? Or the change in displacement over a particular time interval. Now let us take the initial time is 0 and now so here it is 4 seconds. So the time interval is going to be 4 seconds, whereas the displacement is going change in displacement with respect to origin is 8. Let's take it as 8 meters. So the final displacement position vector minus initial is 0 of course, and the time interval is 4 minus 0, which is 4. This gives us 2 meters per second. So this is the average velocity of the object. But if we see interestingly, the graph is a straight line. What does this denote? It means that the object is displacing itself at the same rate every second. That's why the graph is a straight line. So the moment we see a graph of displacement versus time which shows a straight line with a slope, then the object is moving with uniform velocity. That means at any point if you see, it will be moving at 2 meters per second. It doesn't change and it's moving in the same direction because velocity is a vector. If it changes, it will become minus 2 meters per second. So why did I say with a slope? If I have a displacement time graph like this and the line is a straight line without a slope, it's parallel to the time axis or the x-axis, then the object has not changed its displacement. It's been in the same position. In this case, there is no velocity at all. So it has to be a line with a slope, which means the object is accelerating the object is moving at the same velocity throughout. But in real life scenarios, this is not the case. Objects, if you take a car on the road or if you take any object that's moving around randomly, it tends to change its velocity. Or every second, if you measure, the amount by which it has displaced itself from the original position keeps varying. So the graphs are typically something like what you see here, this or this. Let's look at these graphs. Again here the velocity, let's try and measure the velocity between time intervals t2 and t1. We know that velocity is change in displacement by change in the time, in this case the average velocity. So it is the final displacement minus initial displacement. We can call this average velocity sf minus si by t2 minus t1. And here too the average velocity is going to be sf minus si by t2 minus t1. But what's interesting here is that the object has moved. The object has moved and come back to the same position. If you see here, it started from this point and it has moved around with a particular speed. It has gone in some direction, but again it has come back to the same position where it was at the original starting point. So this means that though the object has got a speed, it does not have a average velocity for the entire journey. The average velocity is 0. But it would have had instantaneous velocities. It would have had a velocity here, it would have had a velocity here, because it's moving with some magnitude of speed in some direction. So definitely it has got instant. But throughout the journey from t1 time to t2 time, if you see, the average of all these is 0, which means the object has not displaced itself between t1 and t2. Maybe between t1 and maybe another time interval here, it will have some value, but not between t1 and t2. Let us try and dig a bit little deeper into this. If we have an object which moves from, let's say, point A and comes back to point A, if you see carefully, there are two arrows here. Initially, let's say it goes in this direction and then comes back along the straight line back to point A. But when it goes, let's name this as point B. When it goes from A to B, it is taken 1 second and it's moved at 10 meters per second. When it moved from B to A, it has taken 2 seconds and it's moved at 5 meters per second. Obviously, the total distance between A and B is 10 meters. So initially, it's gone fast. I'm trying to compare it with this graph. If you see the initial slope till this point, it's a rapid rise. And then rather little slowly, it has come back to the time axis. So in the initial section, if you see here, the velocity is more, which we can assume it's 10 meter per second, let's say. So it has gone from A to B quickly compared to B to A. But how there are so many velocities here, like it's got 10 meter per second, it has come back at 5, then how is the average becoming 0? Let's try and find that out. See, if you look at it from A to B, then the velocity is 10 in this direction, right? The velocity is 10 meters per second. If you call this as a vector velocity, it's 10 meters in this direction for 1 second. Then when it comes from B to A, the velocity is 5 meters per second in this direction for 1 second, and again 5 meters per second for the next second in this direction, as shown by this arrow. So if you consider this as the positive direction, then we have a plus 10 for 1 second, then we have 2 minus 5s for the second and third second. When we add all of this, the net becomes 0. So it's very clear, therefore, that though the object has got various velocities at various points and it's actually not been at rest at all, average velocity is 0. So this is what I was trying to share with you on average velocity and uniform velocity, so on. Thank you.